Alright guys, you're welcome back to a continuation of the lecture series on information retrieval and text mining. Today we shall be looking at how we can evaluate our information retrieval model and what is the reason behind the evaluation. Number one, there are many retrieval models what you call algorithm or systems. So how do you choose the best one? And the other thing is, what's the best component for each of these parts that make up the IR system? Because we need to rank the returned document. So, and there are various ranking functions which we can use: the dot product, the cosine similarity, Jaccard coefficient, and the likes. In selecting the term in our query and also in the document, that is in tokenization, what decision should we take? Should we remove stopwatch? Should we stem? Should we do should we reduce words to their dictionary format, the dictionary based word? uh, so that is lemmatization. Should we lemmatize? Term weighting. There are various ways we can weight each of the tokens that we can weight our term. Should we weight our term by the number of times they occur in a particular document, that is the term frequency? Or should we weight it by the number of times they occur in all the documents, that is the document frequency? Or should we weight such a way that terms that occur in that occurs in a particular document but less in other document, which is the inverse document frequency? Or should we use both the term frequency and the inverse document frequency? So these are decisions we can make. So when we rank the returned document, how far down are we sure the user will be able to look before the user gives up on our result? So we want to make sure that we don't give the user too much on a single page. So these are some of the things that will go into our system evaluation. So what are the difficulties involved in evaluating an information retrieval system? One is effectiveness is related to the relevancy of retrieved items. And what that means is that every IR system in a way is going to return some items, some document. But to measure how effective that IR system is dependent on how relevant to the user the items that are returned. And relevancy is not binary. We know now that it's continuous. And even if the relevance is that, it can be difficult to judgment to make, to evaluate. Remember, we're evaluating different IR systems. Because if I have IR system A and IR system B, and they both return 5 documents, so how do I measure that? Okay, the 5 document returned by IR system A is better than the 5 document returned by IR system B. So it's difficult to make that judgment. So from a human standpoint of view, relevancy is subjective. That is, it depends upon a specific user's judgment, and users can differ from one to another. So the result that I get from my IR system, I may be satisfied with it. Somebody else might get the same result and may not be satisfied with it. So it's subjective, it's user specific. Situational, that is also very informative, depends on the user's current need, which still comes back to the user. Is it timely? Is it based on what the user actually expected at that time? Cognitive, it depends on human perception and behavior, and it's dynamic, changes over time. So if an IR system A is better today doesn't necessarily mean that in a month's time the IR system will still be the better one. So these are difficulties involved in evaluating multiple IRs information retrieval system. So the human label corpora, which is the annotation, the gold standard, we start with a corpus of document. That is, this is how we prepare we compare the result from the higher system compare with that of the human judgment. So we start with a corpus of document, in thousands or couple of hundreds of thousands of documents. When we collect a set of queries for this corpus, you know for sure that we cannot possibly collect all possible queries that will be used in the future. But we just collect a set of hundreds of queries for the corpus that we're going to use to test the document. So one or more human experts will exhaustively label the relevant document for each query. And that is very time consuming. What that means is that, okay, you're going to have, let's say you have like 10 queries for instance. So for each query 1, the human expert will go through all the document, the hundreds of thousands, and is going to put each of those documents in a bucket of relevant or not relevant to the query. You see, this really is very time consuming, and this typically assumes binary relevance judgment, and that is true because the human expert will just, okay, it is relevant or it is not relevant. The human judgment cannot say, oh, it is 90% relevant, this one is 70% relevant, this one is 50% relevant, this one is 30% relevant. So it's difficult for the human annotator to make that kind of scaling, that kind of graduation. So, and that requires a considerable amount of human effort for large document and query. And if you don't do this for a very large document, it really does not make the work meaningful. So these are intrinsic challenge into evaluating an IR system. So one of the important metrics that are being used in measuring an IR system performance is precision and recall. So we'll go about it. Number one thing that is very important for us to know is that we are concerned with the number of relevant documents retrieved. You will see that in both of them, the number of relevant documents retrieved. So we have an entire document collection. We have retrieved document and we have relevant document. So we have set of documents that are relevant. We know that in a collection, it's not all the documents that will be relevant. And in a collection, it might not necessarily be that all the documents that are retrieved. So let's say this is the circle of the relevant document and this is the circle of the retrieved document. So the match of the retrieved and relevant tells us, give us a pointer of what the system was able to do correctly. So in this case, this intersection of relevant and retrieved is the point that measures how well the system has been able to perform. So the recall is number of relevant documents retrieved, and you know that we are judging the IR system. We know the number of relevant documents based on the human annotation. So we're going to compare the number of documents that the system retrieved, then we mark it based on number of relevant documents. So we check out of the retrieved document how many of them are inside the relevant annotation. So that's the number of relevant documents retrieved divided by the total number of relevant document. That is recall. So recall essentially just measure the system based on the human annotation. So we know the total number of relevant documents based on human annotation. Then we want to check how many of that did the system get correctly. On the other hand, precision measures the IR system based on itself. That is, check the number of relevant documents retrieved based on total number of documents retrieved. So precision is essentially penalizing for noise, trying to look for noise in the document retrieved, because the IR system might just decide to return every document as relevant, and that means it will have a very high recall. But then by the time we use precision, we will discover that system is going to have a very low precision, but because this will be add up to a lot of noise, so that means the system is not precise. So this is a contingency table to show us what we talk about. So we have this plotted. We have on this side, this is the relevant document, and this is the non-relevant document. This is the retrieved, this is not retrieved. In some other like machine learning, we also call this a confusion matrix. So relevant is we know relevant by human annotation. So this is like annotated, this is like actual by the human. So retrieve, this is predictions, this is what the IR system returned, so not retrieved. So essentially now we know what is relevant and we know what the system returned as retrieved. So this is W. Again, we know what is not relevant and we know what the system is not retrieved, that is Z. Okay, so essentially we want to maximize this W and this Z and minimize X and Y. So relevant, not retrieved, we have to penalize the system because the human annotation says these are the relevant document, but the system did not retrieve it. We want to penalize it. Not relevant and retrieved, the human annotation says, oh, these ones are not relevant, but the system is just retrieving them. Those are noise. We want to penalize the system. In another way, so relevant but not retrieved, we call this one false negative. Not relevant but retrieved, we call this one false positive. This is a false alarm. It's not relevant as the document, the IR system is saying it is relevant. That's false alarm, so false positive. So now we see how we measure our recall and precision. So recall is W, that is this, relevant and retrieved. So these are W, relevant and retrieved, divided by W plus X, that is relevant and not retrieved, so W plus X. On the other hand, precision is W over W, that is on the diagonal on the column, plus Y, that is not relevant and retrieved. Alright. So from all documents that are relevant out there, how many did the IR system retrieve? Precision, for all documents that are retrieved by the IR system, how many are relevant? So precision is actually self-evaluation. Alright. So precision, the ability to retrieve top-ranked documents that are mostly relevant. Recall, the ability of the search to find all of the relevant items in the code. all of the relevant items, while precision retrieve top ranked document. So to determine a recall is difficult. Based on what we said earlier, that it's a difficult task for the human annotation to annotate all possible documents. Total number of relevant items is not always available. Sample across the database and perform relevance judgment of these items. So that's mostly what is done, just do a sample. So apply different retrieval algorithm to the same database for the same query. So the aggregate of relevant item is taken as the total set. So since it's difficult to do that for all, so we just do sampling. So what's the trade-off between recall and precision? And this shows that typically we want a system that has the recall to be 1. So the recall is 1 here. And a system that also has the precision to be 1. So our ideal system will be a system that is in this region. But this is not always possible. So really return relevant document but misses many useful ones. So in this region, the recall is like 0 and the precision is 1. So it returns relevant document, but it has missed out the useful one. Its recall is 0. In this region, the recall is 1, but the precision is close to 0. That means having junk. So return most relevant document but includes lots of junk. And that's what I said earlier. It's precision. So how do we compute recall and precision point? We continue from that the next lecture. Thank you for listening and see you in the next one.